Welcome to another very quick tutorial. This one here is on the topic of volumetric analysis. You absolutely must have seen the previous tutorial, which is called concentration, in order to understand or get the most out of this tutorial right here. Okay, let's move on straight away to the introduction. Volumetric analysis is a fancy name for the way we can go through and calculate or analyze a concentration of an unknown substance. Like, for example, here's my little jar. It is filled of liquid, but I do not know how many moles per litre of the substance is in there. I know that it is sodium hydroxide, for example, but I have no idea what the concentration is. Well, I can do an analysis of it. I can analyze it using certain volumes of liquids that I'm pouring into it. But there's a few things I must know first. First of all, I must have a chemical of a known concentration I am reacting with it. Okay. I need an indicator to tell me when all the chemical has been used up or reacted. And I need a number of pieces of equipment that can measure the volume accurately. And we're going to go through and see the entire process of this over the next few pages. Okay, here are the equipments, the pieces of equipment. First of all, we have a pipette. A pipette will always have a very specific concentration on it. For example, this pipette here measures exactly 50 mils. Excellent. So, for measuring accurately and precisely exactly the right volumes. Okay. A burette. Okay, I need to get rid of that ink. A burette is a fancy name for a device. It's very similar to a measuring cylinder, but it's got a tap at the bottom. So if I turn the tap, then all this liquid will start pouring out the bottom, and then the volume will start going downwards. The liquid will start being lost from the burette. Okay, moving on. I need a conical flask for mixing the two solutions together. I am going to need a wash bottle because everything must be cleaned when we use this stuff. Last thing you want is other chemicals in there messing up the concentrations of your experiments, because they could be reacting with it. So we need to get exactly the right amount of chemical reacting. So we need to clear out all the old chemical from our equipment first. Notice it contains distilled water. That is because distilled water has got no chlorine or fluorine or other sort of additives in it that could be causing problems. Okay, a funnel, boring. And last of all, a volumetric flask. These are special little flasks that we use to make up exactly certain quantities of liquid. For example, this 50 ml volumetric flask here, you can't really see it there, but there's a little line running across there, and when my little meniscus is dipping at exactly the right space on that line, okay, I've got exactly 50 mils. So if I've got exactly 0.25 moles of the substance in 50 mils, I know the exact concentration of that substance, because concentration equals N over V. Okay, let's move on. Here's the process though. Now, first of all, you need two solutions. You need the one that you don't know the concentration of, the solution of unknown concentration. Okay, and you need a solution of known concentration. We call the known concentration the standard solution. It's the standard. If I said, I want you to meet the certain standard, okay, I'd have to give you an example of what you would have to meet. For example, your ties must be arranged exactly like this, just like Fred's. Okay, so your ties have to meet the standard that Fred is. Okay, so a standard solution is a chemical solution that we know the concentration of as a certain standard. Rightio. Moving on. We also need to know how to write a balanced equation for the reaction between your two chemicals. Okay, and then we must make sure we've got all our glassware nice and clean. So before we do it, we're preparing. We've got our two solutions. We've got a balanced equation for the reaction, and all my glassware is nicely cleaned up. Okay, I've used distilled water to go through and and clean everything. But really importantly, the pipettes and the burettes, they'll be rinsed with the solutions that we are going to eventually add into them. Why would we do that? Well, imagine you've got a pipette, right? Here's my little pipette there. Okay, and I've rinsed it with distilled water, and there's still a little bit of drips in there of distilled water. Then I go through and suck up this very, very precise solution into my pipette, and we actually end up getting diluted as I start putting more and more, as that liquid in there already gets sucked up, it'll actually mix in there and dilute it. So I rinse it out with the solution first, so suck it a little bit up, then swish it around and spit it out again. Okay, not spit it out, empty it, of course. And the burette, the one with the little tap at the bottom, there's a little tap, pretend that's a tap. Okay, I've got to suck it a little bit up into there, rinse it out, and then empty it again. Rightio, let's move on. Here's the setup. Okay, first of all, I'm going to get a burette. That's that big thing. I have gone through and I've rinsed it with the distilled water and then with the solution adding into it. Then I have filled it with the chemical that I'm adding to it. And it is going to be actually end up being attached to a clamp stand. Okay, there's my clamp stand right there. Okay, and it's holding the burette up off the ground. Or in this case here, just above the flask. Now, by the way, eventually once you've got it set up, you will lower this burette down so that the flask will end up sitting inside it, because you don't want to lose any drips. When you start doing this tap, the last thing you want is your flask to sort of move out of the way slightly and then the stuff to go all over the ground. You have to start it all over again. So make sure that the tip of the burette is sitting inside the flask. Step 1. I am going to fill up my burette with one of the solutions. In this case here, this is going to be this is the volumetric flask, and I've made up a standard solution because I know the exact amount I put in, I know the exact volume I put in, and so therefore it is now the standard. So in this case here, I'm putting the standard solution into the burette. I don't have to put it there. I could actually end up putting the standard solution down the bottom later if I needed to. Okay, so step 1, I fill up the burette with one of my chemicals. And I also make sure up here that it's below or at the 0.0 mark. If you go above the 0.0 mark, you don't know what's up there. So you've got to bring it down to the 0.0 mark, or above, below. It depends what you're looking at it. That's because it goes like 0, 1, 2, 3, 4, 5. So if that's the 0 mark there, it's got to either be at the 0 mark or down the burette from that. Rightio. A pipette, this little pipette right here, of course these things are not to scale. I've used it to suck up an exact volume of liquid, and then I've popped that volume of liquid, I've popped it into these flasks. And I've gone through and I've made a number of those flasks. I've actually gone through and produced a number for lots and lots of repeat tests. So every single one of those has got exactly 50 mils in, because that's what my pipette measures only. At the 50 mil mark at the top, 50 mils exactly in each flask. Okay, how much time do we have? 6 minutes. Excellent. And last of all, I'm going to go through and add some indicator. Just a drop or two into every single flask, and this indicator will tell me when my reaction has finished. Okay, so that's the process, the setup. Here is the titration itself, the method that we are going to use in order. Okay, first of all, step 1, I'm going to read the initial level of the liquid. For example, let's say it is 0.15 mils at the top there. Okay, so I've measured the initial volume. Cool. I have turned on the tap and I start swirling the flask around. Okay, so I'm turning the tap, I'm pouring the liquid out of the burette, and it's going into my flask. Rightio, and I'm swirling it around, swirling. The indicator will begin to change colour. And when it does, we start slowing down the flow. So this tap that we've turned on, okay, turn the tap on, I'm going to start turning it back again in order to slow the flow. Then, my liquid's dropping and dropping and dropping and dropping and dropping. Ching. When the color changes permanently, and this, now you're looking for, okay, there it goes. You're looking for the time when the liquid goes pa-ching and changes, that single drop that you've put in there that changes the color permanently. Then we stop the flow of the liquid and we read the final volume. Let's say it's gone down to 12.00. Cool. And that is my final volume there. Okay. Then what we can do, well, we absolutely write down the two things. There, how much liquid have I used? Well, I've gone from 0.15 down to 12.00, so I've used 11.85 mils. How did you work that out? Well, I had 12.00 and I minus 0.15 from it. I better make sure that is correct, because my maths is absolutely shocking. 12 minus 0.15 equals, yep, I got it right, excellent. This volume here is called a titer. It is the amount of liquid that has come out of the burette. Okay, and we are going to go through and repeat the titration with a brand new flask now that you know the rough volume required. So hopefully I'm going to get like 11.85, and next time I'll get 11.85 again, and then I'll get hopefully 11.85 again. I might next time get all, you know. So you're trying to get the volumes to be as close as possible. And the first one we sort of call a rough volume, because you're getting a general indication, and sometimes you might accidentally go overboard on the first one because you weren't expecting it to stop when it did. Remember as well, as your volume starts going further and further down, watch out as you go down the bottom, because eventually you're going to run out of numbers. Okay, so you've got to go through and re-top up your burette. Okay, so we're aiming for precise results. Precise means as close as possible to the same number. Hopefully also they will be accurate also. Accurate means close to the target of where they should be. Okay, cool. For example, here's a target. Precise means I'm hitting exactly the same spot each time. Accurate means I'm hitting the correct spot. Okay, so this one here was precise, but it was not accurate. Why is that? Well, if it was a bow and arrow, for example, it could be that I'm just sighting it in the wrong place. So sure, I'm hitting the same spot every time, but all I've got to do is just lower my aim down a little bit to get it in the right spot. Okay, calculations. Do we have enough time for calculations? No. I'm going to leave it there and continue the rest of the tutorial very, very shortly on this topic right here.